Are you starting your data science journey and confused about whether to learn SQL or PySpark? Both are powerful tools, but which one should you prioritize? In the next 3 minutes, I'll break down everything you need to know. We'll cover SQL Basics, PySpark fundamentals, compare them head-to-head, and I'll give you clear guidance on which to learn first. I'm here to make this decision simple for you. Let's start with SQL. Let's start with the bedrock of data management, SQL, or Structured Query Language. For decades, it has been the universal standard for communicating with relational databases, the kind that organize information into neat tables with rows and columns. It's the foundational skill for anyone working with structured data, used by popular databases like MySQL, PostgreSQL, and SQL Server. Think of it as a way to talk to your database. SQL is declarative. You don't tell the database to get data, you simply declare you want. You write queries like, select name, age from customers where age is greater than 25. Here specifies the columns, the table, and filters the results. This simple syntax can join multiple tables for a complete business view or aggregate sales data. The database processes your request, optimizes the path to the information, and returns a formatted result. SQL is easy to learn, widely used, and perfect for structured data on a single server. However, its architecture has limitations. When faced with massive petabyte-scale data or complex iterative algorithms for machine learning, a single machine becomes a bottleneck. This is a problem of vertical scaling. You can only make one machine so powerful before hitting a wall. Now let's look at PySpark, which solves this with distributed computing. PySpark is Python's interface to Apache Spark, an engine built for big data. Instead of one server, Spark uses a cluster of machines. It breaks down data and tasks, distributing them across the cluster to be processed in parallel. This horizontal scaling approach means it can handle datasets of virtually any size, making it the go-to for large-scale data transformations and training machine learning models. At its core, PySpark lets you write familiar Python code to control a powerful distributed computing engine. Your script, on a driver node, intelligently breaks down tasks and distributes them across a cluster of executor nodes. This parallel execution is the secret to its massive scalability. Imagine analyzing a decade of e-commerce logs on one computer. It would quickly run out of memory. PySpark sidesteps this by processing data in parallel across many machines. This horizontal scaling makes it possible to work with datasets measured in terabytes or even petabytes, turning impossible tasks into routine analysis. PySpark's strengths are versatile. It excels at building robust ETL pipelines. Its native MLlib library lets you train models on distributed data without downsampling. And with Spark Streaming, you can analyze live data for applications like real-time fraud detection, creating a complete ecosystem for large-scale data work. However, this power has trade-offs. The learning curve is steeper, as you must grasp distributed concepts like lazy evaluation. Cluster setup can be complex, and for smaller datasets, the overhead of starting a Spark session can be slower than alternatives. Plus, running a cluster requires significant computing resources. So when choosing between traditional SQL and PySpark, how do you decide? Let's break down the comparison to make the choice clearer. For data size, SQL databases scale on a single server, handling gigabytes with ease. PySpark scales by adding more machines. This makes it the clear choice for terabyte-scale data, where vertical scaling becomes impossibly expensive. Regarding speed, context is key. For a simple indexed query, a tuned SQL database is incredibly fast. But for complex multi-stage transformations on massive datasets, PySpark's parallel in-memory processing is orders of magnitude faster, avoiding the bottlenecks of a single machine. When it comes to the learning curve, SQL is famously beginner-friendly. As a declarative language, its English-like syntax lets you state data you want, not the complex steps to retrieve it. PySpark, on the other hand, requires intermediate skills. You need a solid foundation in Python and must also grasp concepts of distributed computing, like lazy evaluation and cluster architecture. You're programming a data workflow which is inherently more complex. Their ecosystems are also distinct. SQL is the native language of relational databases like PostgreSQL and integrates seamlessly with BI tools like Tableau for reporting. PySpark thrives in the big data world. It connects to distributed storage like Amazon S3 and powers large-scale processing on platforms like Databricks. It's the engine for building massive data pipelines and training machine learning models on datasets too large for a single machine. So, with these differences in mind, which one should you learn first? If you're a complete beginner, start with SQL. It's easier to learn and builds the foundational database skills essential for any data career. Understanding relational logic, joins, and aggregations is a non-negotiable skill for data analysts and BI roles. Most data jobs require SQL, making it the most direct path to getting hired and a crucial stepping stone to more advanced tools. Choose PySpark. If you're already comfortable with Python and your goals involve big data engineering or advanced analytics, it's the go-to for building large-scale ETL pipelines or training machine learning models on massive datasets. Its strength is parallel processing, making it essential when data volume exceeds the capacity of a traditional database. The ideal path for most is to learn SQL first, become proficient in Python, then move to PySpark. This progression mirrors how they're used together. A data engineer might use PySpark to transform raw data and load it into a data warehouse. From there, an analyst uses SQL to query that structured data for business insights. They are powerful collaborators, not competitors. Ultimately, start with what matches your current needs and career goals. But remember, these tools complement each other. To build a versatile and future-proof career, plan to learn both eventually. This dual expertise will make you an invaluable asset in any data-driven organization, ready to tackle challenges at any scale. To summarize, SQL for beginners and structured data, PySpark for big data and advanced analytics. Which tool are you planning to learn first? Let me know in the comments below. If this helped clarify your learning path, hit subscribe for more data science guidance. Thanks for watching and good luck on your data science journey. See you in the next video.